String theory is a theoretical framework in physics that aims to describe the fundamental structure of the universe by modeling subatomic particles as one-dimensional objects called strings. According to string theory, particles are not just point-like objects, but rather tiny, vibrating strings that can exist in multiple dimensions. String theory was developed in the late 20th century in an attempt to unify the two major theories of physics at the time, general relativity, which describes gravity, and quantum mechanics, which describes the behavior of subatomic particles. String theory proposes that all particles are made up of strings that vibrate at different frequencies, and that the properties of these strings determine the characteristics of the particles they compose. One of the key features of string theory is that it requires the existence of extra dimensions beyond the 4 dimensions of space and time that we experience in everyday life. These extra dimensions are compactified, or curled up, so that they are too small to be detected directly. The idea of extra dimensions is a departure from traditional physics, but it is necessary in string theory to explain certain phenomena. String theory is still a highly active area of research, and many questions remain unanswered. Despite its theoretical elegance, it has yet to be confirmed by experimental evidence, and its predictions have been difficult to test. Nonetheless, string theory has had a major impact on modern physics and has inspired new ways of thinking about the fundamental nature of the universe. In addition to the basic idea that particles are composed of strings that vibrate at different frequencies, string theory has many other fascinating features and implications. Here are some additional points to consider. String theory predicts the existence of new particles called gravitons, which are hypothetical particles that mediate the force of gravity. In traditional physics, gravity is described as a curvature of space-time, but string theory suggests that gravity arises from the exchange of gravitons between particles. String theory suggests that there may be multiple universes or parallel worlds that exist alongside our own. This idea arises from the fact that string theory requires the existence of extra dimensions, which could in theory be curled up in different ways to create different universes with different physical properties. String theory has connections to other areas of physics, such as black hole physics and the study of exotic states of matter called quark-gluon plasmas. These connections have led to new insights and advances in these areas of research. One of the major challenges facing string theory is the fact that it requires extremely high energies to be tested experimentally. Current particle accelerators are not capable of producing energies high enough to detect the predicted effects of string theory, which makes it difficult to confirm or refute the theory. Despite these challenges, string theory has inspired a great deal of excitement and interest among physicists and the public alike. It remains one of the most active and promising areas of research in theoretical physics today.